Bonus question on the file will be like, do a tragedy.
I'm Zen.
Hello, good morning. How are you?
Good.
Good, good. You have a good week?
Yep.
All right.
It was really easy to fill in the blanks.
Yeah, these last couple lessons, like I said, they're real light.
I think our lab is the Rube Goldberg machine.
Yep, it is. We are starting it today. All ready to go out there. It's gonna be awesome. I'm excited. You excited?
Yep.
I'm excited. It's gonna be a lot of fun.
I was trying to figure out how I have to solve this.
Oh, yeah?
This looks like it's pretty easy.
Yeah, PJ does that. PJ does that.
Really is good at programs.
Yeah, she is.
So let's just.
Yep. Hey, you made it. I thought you were gonna be late. Was it your mouth that had the problem this morning? What happened?
Sensitivity in this too.
Yeah. Good job.
That's it.
When your molars is sensitive?
Yeah, in between two teeth
Yeah.
and yeah.
What was it?
You don't know.
Oh, you don't know? Yeah. Can't find anything. You're not grinding it or whatever.
Yeah.
Not causing problems to your root. When Cole was little, he had a tooth. Fortunately, it was a baby tooth. But he had been like grinding his teeth at night and he killed the nerve and the tooth like super duper hurt. And our dentist came in on a Saturday and pulled it for him because it was causing him so much pain. So are you numbed up or you just hurt? I'm sorry. Did you at least take some Tylenol or ibuprofen or something?
No, I don't want to. It doesn't hurt that bad.
No.
Not right now. It hurts. You got a tooth? No, not right now, but I do get some. I got a really bad toothache.
You did? Why?
Before I went to India, I ate. In the night, I woke up I stood awake the whole night.
Oh, no.
Because of the toothache. I couldn't go to another class because of the toothache.
Yeah.
So we had to take that tooth off.
You pull it out. Yeah.
And then it became better. One time I had a cavity, but it wasn't in the inside. It wasn't going outside in, it was inside out.
Oh, how'd that happen?
I don't know. And then I had to have a root canal and it got infected.
Yeah.
And it was like really painful.
Where's your root canal? Back here somewhere? On a permanent tooth?
No, yeah.
Yeah, 6-year molar or 12-year molar or whatever. You can play the fun trick though, of like putting ice on it and it never gets full.
Yeah, I put ice on it and it became even worse.
Yeah, well, when you have a root canal, the nerve is dead, so like your tooth is there, but it's not really like alive like it was in some ways. Like it doesn't have the nerve thing, so it can't feel pain. So like you can put like an ice cube on it and it never hurts. So Drew has 2 in the front that he damaged. Both 2 of his front teeth have been root
I
canals.
still love the dentist.
Yeah.
Now I love because of the lollipop.
Yeah. Always love them. Now
My
he
sister loves
actually.
the dentist because she gets
a lollipop.
toothbrush and all those Colgate and.
Oh my goodness.
And she like, yay, when she comes home.
Oh my goodness.
That's the reason I like that. I just thought the dentist was fun, but now I don't because of that root canal.
Yeah.
How much pain?
Did it hurt? The root canal hurt? Or beforehand?
after.
Really?
Yeah.
Drew was not bothered one bit?
It was, that's because mine got
Oh,
We
yeah, I
are
don't know it. Hey.
early. The
Yeah.
entire side of my face was swollen.
Yeah, we'll do it. Did you get to the Masters?
Yes.
You go? Yeah, was it cool?
Yeah.
Jason went a couple years ago with some customers. He enjoyed it, so.
Yeah, my dad, one of my dad's investors in his company.
Yeah.
His father-in-law is chairman of Bank of America.
Oh, okay.
So he's a member there.
So you get some good,
Yeah, behind the scenes.
good behind the scenes
Yeah, last
stuff.
time he stayed over, but this time it's just like I'm too tired because I just got back from skiing.
Yeah, yeah. Well, that sounds like
Don't
fun.
mind my too short pants.
Hey, girl.
Since I was
They're for
born.
working outside, right? That's the
Yeah.
point. Yep.
Last week was tech week for the ball club.
Yes, I heard.
And so that was exhausting.
Mm-hmm.
And I have this, sleep.
We'll get you woken up. We'll get you up and moving.
I was watching family.
Today's a really short lesson.
Yeah, it's gonna be a neat.
Play some games after.
We have kind of a guessing game to play during the lesson,
Oh.
and then we'll be doing our build, which will be great. And it'll be fun. Are you cold? See, I'm finally comfortable. I'm always hot, so.
I wish I could.
That's why I always tell people, bring extra warm snuggly clothes, cause I get cold. I mean, I got to get it cold.
How far are you? 15 minutes?
They're just on the other side of the river.
Yeah, literally our neighborhood's on the other side.
Mhm.
Sometimes we get so.
If we could walk across water, we could walk here.
Yep. I had a friend from church who used to live on Bighorn Hollow over there in your neighborhood.
Do you guys know where the Swanee water, let's not.
30. Do we know where what is what?
Swanee water tower is?
Yep,
That's my house.
yep, I know, you're right at the base of the water,
I'm
like
in-
quite
I'm
literally.
in James Street.
Yep, I know where you are
If
too.
we owned it, it would be a part of our property.
Yep, cause it's like right in the middle of your yard.
Yeah, our lesson there is short today.
Yep, it's a short lesson. These next couple lessons are short. It's gonna be good. We got lots of time. Really, we only have like.
It's like in Boston.
What's that?
You
That's
solved
a
it yesterday,
puzzle.
like, you solved it last week in 2 minutes. No, I didn't. I solved it. It's you.
No.
Someone solved that, yes. Well, PJ.
We got a guy on Drew's gymnastics team who is a Rubik's master. Like, he just got 2 more. He's
They spent their
crazy.
time in lockdown figuring out Ruby.
He is
got
good.
I got a 15-second solving Rubik's Cube.
Do you really? No, I can't do them. I think they're cool, but I get the idea, you know, that there's a certain choreography to
I
it,
need
but
the patience.
there's that too, you know?
Wait, you don't have patience? I do. I'm a golfer, so yeah, I do.
Yeah, you gotta have some patience.
I'm paper macheing a hammerhead shark
Oh, okay.
because I saw a 30-second YouTube video and I was like, I'm gonna do this now.
Is it lights out?
No, it's just like that big.
Every time I press it, it goes out. That could be a.
I'm gonna show you guys real quick, if I can move this
Is it
over.
scale?
It's not to scale.
This is our, so that our dance, let's see, I've got, Emma, you've got dance tickets. I don't think you guys have tickets. Are you gonna come?
I'm not sure when is this dance?
It's the 10th. And it's always super fun.
We have a tournament.
Oh, do you? What time's your tournament?
It's a 2-day tournament.
Oh, so will Darcy be gone too, or?
I probably have some extra gymnastics practice.
It's not till 8 p.m. So if you want to come, it'll be fun. It's like 8 to 11. It's always fun. We have food. We take nothing but requests all night long. We got a good sound system. We got flashy lights. It's woo.
I finally solved one color somehow.
There you go.
At breakfast.
Goodness, girl, you're falling apart.
And I woke up at 9:05. Best sleep I've ever had.
All right, so just so y'all know real quick before we start, we got lesson 30 today. And we're doing chemical bonds, next week's chemical reactions, and then there's acids, bases, and solutions. And then,
Bonds was today, lesson 30.
yeah, it is chemical bonds, then chemical reactions, acid, bases, and solutions, and then our final exams. So we are like getting there. And over this next couple weeks, if there's time at all, we'll pop in and we'll do a slideshow or, you know, one of the review games or whatever, just to kind of start getting in your head. Next year's already done. Like, this is next year's schedule. It's already out on the website. So if you want to know what's going on next year, It is already going.
I have 6 pages of science notes, from just the slides so far. I'm determined to get an A plus.
Look at you, girl. I love it. I love it.
Honestly, what I did is the night before midterms, which I did pretty well, and I just went over the slideshow with the thing.
Mhm.
I mean, I wouldn't say I aced it, but I did do very good.
If you can do the slides,
Good at midterm.
if you can do the slides, if you can do the
Jeopardy?
Jeopardy, and if you have those formula triangles and know how to use them, and you'll be allowed a note card like you were at midterms, that's going out in this week's email, all that information, you'll be fine. Like really, you'll be fine.
I was like a pre-made.
Yeah. All right, let's roll here. So let's get this lesson going. So we're talking about chemical bonds this week, which are the attractive forces that hold atoms or ions together. Okay. Now we have 3 main types of bonds. One of them is subdivided. Oh, I think, hang on, let me let Carlos and Nico walk through. Here they come. Good morning, Dad. Here, look, this was slide number 1. Slide number 2. And here we are. All right, Emma, you want to give me one of these?
And I give
Not states of matter. Chemical bond types.
covalent bond.
Covalent one, uh-huh.
Polar covalent bond.
Wait a minute, hang on. Do you know a different one?
Yeah, covalent.
So
Ionic.
ionic, that's what we're looking. All right, we're looking for ionic. And then you said covalent, and those are polar and non-polar. And you know what this next one would be, Emma?
Crystal.
Okay, so metallic. So crystal is, ionic bonds tend to form crystals. So that's probably what you're seeing there.
I'm not even gonna try to pronounce that word.
Which one?
Methane.
Oh,
Methamphetamine.
methylene dioxymethamphetamine. Methylene dioxymethamphetamine. I think this is Adderall, if I'm not wrong. But I would have to double check it. So
Right, you could just be saying that a compliment.
we're gonna go over a bunch of definitions. So this is a good opportunity to earn coinage here. Okay, so first off, what is a compound composed of ions bound together by electrostatic attraction? Does anybody know what that would be? Do you know? Do you want to give it a stab, Eunice?
Crystal.
No, ionic compounds. So ionic compounds involve ions bound together. And ionic compounds, we'll talk about it, but they're always made of 2 types of elements joined together. And we'll do a lot with them next year. Ionic bonds are very, very strong. Covalent bonds tend to be a little weaker. So one lab that you can do to actually see the difference between ionic and covalent bonds is you can take a little salt and a little sugar and a crucible. So a crucible is this little tiny ceramic pot with a little lid. And you put it on your ring stand and you turn on your Bunsen burner and you heat it up. What happens when you heat up sugar?
It turns into
Caramel.
Yeah, it melts and it caramelizes and then it turns into like just straight up carbon, right? Like just like black soot, right? Because the energy from the heat is going to break those covalent bonds. But if you heat up salt, what happens?
nothing.
Nothing. That's right.
Glass like with sand.
With sand, you got to get it super hot. So anyway, ionic bonds and ionic compounds tend to be very strongly bonded. All right, so then what is the collection of atoms corresponding to an ionic compound's formula, such as the molecular mass of the compound is the same as the mass of one pole? You don't know this one, do you? Do you want to guess? Yeah. It's called formula unit. Okay. These are just get you a little accustomed to some of these. Okay. A mole. Okay. We're going to talk about moles in first quarter of next year, but a mole is basically a way to measure things. We use it as a way to measure tiny things. And there's a big number in scientific notation that goes with it. And that number is basically what you use to determine like how many of something there is. And a mole really can be like, it's like how many of something. It's kind of hard to understand, but when we do it next year, I have a good lesson that helps really explain it.
I created infinity on the Jeopardy.
You did? Okay, how'd you do
I
that?
typed in a lot of random numbers and I created it, and it autocorrected to infinity.
Oh, that's interesting, huh?
I created it.
I didn't know that happened. So what is an ion made of 2 or more atoms? Do we know what that would be? So Louis, do you want to guess? You gonna guess or you gonna?
11.
No, not that one yet. So this one's polyatomic ion. So do you remember what an ion is? So you have ions and isotopes. Isotopes is when you have a different number of what?
Different electrons.
Not electrons, neutrons. Okay, protons determine the element, what element it is. So if your number of protons is different, your element's different entirely. Isotopes have a different number of neutrons, so thus their mass is different. But ions have a different number of electrons. Some atoms are going to have a positive charge and some are going to have a negative charge. But you can have a polyatomic ion where you've got two or more atoms that make up an ion that has, it's basically a molecule with a charge, you know. Okay. All right. So then we have ionic compounds are made up of a metal and a non-metal. Okay. A great example of an ionic compound is a salt. Okay. So any salt is an ionic compound. And when you dissolve the salt in water, you get free ions, which are little charged particles, which is why salt water conducts electricity way better than distilled water, right? If you ever, anytime they're trying to conduct electricity through water, they usually make it a brine, right? So a good example of any of these salts are when you combine these guys over here, okay? These diatomic nonmetals over here, or halogens. Remember, sometimes we call these halogens. These guys with one of these guys. So lithium chloride, sodium chloride, potassium bromide. These are all good salts. Do you know what sodium chloride is? It's table salt. Yep. Okay, exactly. Sodium chloride. Both on their own, dangerous. Sodium has to be stored in like mineral oil because if it comes in contact with water, it explodes. Yeah, it explodes. Straight up explodes. There's great YouTube videos of people throwing little tiny bits and they're soft. It's a soft metal, very soft. Yeah, throw it into a lake and it goes boom. Yeah, it's pretty cool actually.
Tiny bits of what?
And chloride,
Do they use that for grenades?
chlorine on its own, not that one in particular, but chlorine on its own is a very dangerous gas. Like it can really hurt you.
Will we be
Put 'em
using that in
together.
chemistry?
Hmm?
Will we be using chlorine in chemistry?
We will be using some chloride. Chlorine, we'll be using chlorine in compounds, yeah. But chlorine alone on its own is dangerous, but when you put them together, sodium chloride is a salt and salts are essential for life. We have to have them. And we need sodium at the molecular level in our cells. And so ionic compounds, complete transfer of ions, which is stealing and donating, meaning they're not sharing ions. One atom is going to steal the electron from another atom. And that's what makes them ionically bound. And then they form ions, which we were just saying. They're solids at room temperature. They have high melting and boiling points. Like we said, you put salt in a little crucible above your flame, it's not going to melt. It's nowhere near high enough. And they're very strong bonds. And they're brittle. Salt is brittle, right? You ever try to, can you heat salt up and pull it into shapes?
No.
Can you do that with sugar? Yeah, you absolutely can, right? And they're non-conductive, but when in liquid form or solution, they're excellent conductors because when they're in a liquid, they're going to form ions. They're going to release some of those ions, which is why like you can't conduct electricity through a block of halite, through a block of salt. Like that doesn't work. Doesn't happen. But if you put them in water, now you've got a nice, really conductive medium. And they have charges. And so here's ionic bonding. Ionic bonding is a force that attracts electrons from one atom to another, which transforms a neutral atom into an ion. So what happens, this is sodium chloride. So you see right here, you have a one valence electron just hanging out by himself, this one guy. And because he doesn't have any buddies near him, the way it works is this, he's kind of at risk. You see how he's by himself right here? The red one? Okay. Now, basically, that atom would be happier if it didn't have one lone guy in one shell by itself. That shell can hold many more electrons, but it only has one. So that guy's very vulnerable. The chlorine in this case is missing one electron to fill its shell. So atoms are very happy when their electron shells are perfectly full. So chlorine is missing one to be perfectly full. And sodium has an extra that if you took it away, the ones before that one would be perfectly full. Does that kind of make sense?
Yeah.
So that's why they join together, because basically chlorine wants an atom and sodium wants to get rid of it. So chlorine kind of steals it from sodium. It's a complete transfer. They're not sharing it. So an ionic compound is a three-dimensional network of positive and negative ions mutually attracted to one another, and they form crystals. Perfect example again, sodium chloride. Table salt. Is salt a crystal? You ever looked at salt under a microscope? It's a perfect little crystal, perfect little tiny itty bitty cubes. They look like itty bitty ice cubes under a microscope. And if you've ever seen salt in nature, definitely a crystal. Uh-huh.
I have a question.
Yeah.
If you dumped water on a block of salt, would it be conductive or non-conductive?
The water itself would become conductive. More conductive,
What will the salt block?
not the salt, just the water, because you need the ions. All right, so then ionic compounds tend to be harder and more brittle and to have higher boiling points than materials containing only covalently bonded atoms. So here's covalent. So what is a group of atoms that are held together by chemical forces? A molecule is the smallest unit of matter that can exist by itself and retain all of its chemical properties. What do we think? Yeah.
Non-polar molecules.
Those molecules. Yep, molecules in general. All right, so when we talk about atoms bonded together that form ionic compounds, we tend to call them compounds. And when we talk about things that are bonded covalently, we tend to use the term molecule, okay? But you'll hear them kind of tossed around interchangeably. But to make it more clear, we tend to use molecule for things that are covalently bonded. All right, so what's a chemical compound whose simplest units are molecules? That one's going to be a molecular compound. Ah, okay. So you have ionic compounds and molecular compounds, and we tend to call molecular compounds molecules. So the next one would be a combination of chemical symbols and numbers to represent a substance. Okay, what's that?
Formulae.
There you go. Yeah, that's your formula, your chemical formula. Very good. All right. Now, a chemical formula that shows the number and kinds of atoms in a molecule, but not the arrangement of the atoms. All right, this is called a molecular formula. So it'll show you what's in it, but not how it's arranged. An electron configuration notation in which, now this one you probably know, an electron configuration notation in which only the valence electrons of an atom of a particular element are shown, indicated by dots placed around the element symbol. I think this was in your notes. Do you know it?
A chemical compound.
No, you should know this one. Your name's in it.
Mark.
No,
Lewis.
it's called a Lewis dot. Okay. So, electron dot notation, which in particular is Lewis dot notation, is the particular type we're talking about. Yep. So, a structural formula, which this is going to be it specifically, in which are represented by dots, dots in pairs, dashes between. That's your Lewis structure or your Lewis dot notation, which you'll see. And we have one or two examples today. All right, then we have a formula that indicates the location of atoms, groups, or ions relative to one another in a molecule that indicates the number and location of chemical bonds. Do you know that?
A mole.
No, that one's going to be structural formula. So you good over there, boys? So this kind of tells you structural formula. I'll show you these last couple ones. So a covalent bond in which two atoms share one pair of electrons is a single bond. Okay. One pair of electrons is being shared. So you have electron from one atom and electron from another atom, and they're doing almost, you can think of it like a figure eight. They're going between the two atoms. That's a single bond. When you have two pairs or more, you get a multiple bond, like a double bond or triple bond. And then here's this word resonance. We use this word this year, but it's going to be different now. So it's the bonding in molecules or ions that cannot be correctly represented by a single Lewis dot. Nico, what were you going to say?
I was gonna say double bond.
Yeah, double bond. Yep. You have double bond, multiple bond. You can have triple bond. It's just how many pairs are being shared. So our covalent molecules are between a metal and a nonmetal, sharing electrons. Remember, ions steal. In ionic bonds, it's stealing an electron. But in covalent bonds, it's sharing an electron. They form molecules. They can be solid, liquid, or gas at room temperature. Remember, ionic compounds are always solid at room temperature. They have low melting and boiling points. Sugar, again, is a great example. Sugar is a covalently bonded molecule. It's going to melt when you heat it up. Weak bonds, sugar is going to break apart, turn into carbon and other stuff, right? And they can be pretty brittle. And they are soluble in water. If you put sugar in water, will it dissolve? Yes. And they are poor conductors. Does sugar conduct electricity?
No.
No, it doesn't at all. Like even if you make sugar water, does that conduct electricity? No. And whoops, sorry. And then you have two types. You have polar and non-polar. In polar, you have unequal sharing of electrons, and two different nonmetals are involved. And in non-polar, you have equal sharing. So what that would mean is sometimes you've got like 2 electrons over here and 1 electron over here, and they're sharing all 3, but 2 are on one side. And it tends to lead to, it causes the molecule itself to have a charge. So that molecule itself will orient itself towards charges. And a real life example of where this happens. So water is considered like a bipolar molecule. So water has a positive charge at one end and a negative charge at the other end. And when you use surfactants, so a great example is dish soap. You ever had to wash a greasy dish after dinner?
Yeah.
So basically what it's doing is it's trapping the water molecules. It's pulling the water, it works with the water molecules, with the polarity of the water molecules in order to kind of separate the water and the grease. Yeah. Yeah. And we'll do that a little bit next year too. So covalent bonding occurs when atoms share one or more pairs of electrons. A non-polar covalent bond occurs when electrons are equally attracted to both bonded atoms. A polar covalent bond occurs when electrons shared by 2 atoms are more closely held by 1 atom. And atoms and molecules are joined by covalent bonds. In a covalent bond, 2 atoms share 1 or more pairs of electrons. And then there's this thing called the octet rule, which basically states that many chemical compounds tend to form bonds so that each atom shares or has 8 electrons in its highest occupied energy level. You want 8. That's kind of your magic number. And bonding within molecules and ions can be indicated with Lewis dot structure, which we'll see in a bit. So metallic bonds is our third type of bond, right? So we had ionic, covalent, which is polar and nonpolar, and then metallic. Okay, malleability, ductility, conductivity. All right, so malleability is the ability of a substance to be hammered or beaten into a sheet. Can you hammer or beat metal into a sheet? Yes, you hammer metal enough, you can get it into a sheet. Yep. What's ductility? Does anybody know what ductility is? Malleability is its ability to be hammered. I'm sure your dad does, yeah.
It's
So it's similar, kind of not, well, sort of. So it's the ability of a substance to be hammered thin or drawn out into a wire. So malleability is, can I make it into a sheet? Ductility is, can I pull it into a wire? And conductivity, we all know, is what? What?
To make it more or something.
Conductivity. What's something that's conductive does what? Conducts what? What's it conduct?
Electricity.
Electricity, yes, okay, there we go.
Copper wire.
And thermal. So metal conducts both thermal and electrical energy, right? You don't want to touch, like, what do they tell you if you think your house is on fire, do you grab the doorknob?
no,
Why not?
because it's gonna be really hot.
Because it's metal and metal conducts thermal energy, right?
our whole front door is metal, so you don't want to be.
Yeah, you won't be touching
I'd
that.
rather jump out the window.
So metallic bond is formed by the attraction between positively charged metal ions and electrons around them. The electron C formed by metallic bonding gives metals their properties of high electrical and thermal conductivity, malleability, ductility, and luster. Luster is, does it shine? Okay, hydrogen bonding. Now this is kind of like a 4th type of bonding that's really cool. Yeah, James Bond. So hydrogen bonds. This is the intermolecular force occurring when a hydrogen atom is bonded to a highly electronegative atom of another molecule, not another atom within a molecule. And this is what water has. You know how water has a surface tension? You ever see things like small things like leaves float on the surface? Or how about the little bugs, those Orman bugs that can like walk on water? You ever seen them? Watermen or and then, you know, when we measure with, you know how we measure with a graduated cylinder, there's a meniscus, it curves, right? That's all because there are hydrogen bonds, but those are not within the molecule, those are between the molecules. That's what causes water is a great example of hydrogen bonding. So you've got the hydrogens in water molecules being attracted to the other molecules. So an ionic bond, you can see right here, this sodium's one little electron is going to go to the chlorine. And then you see what happens. See, this is a Lewis dot right here. So look real close. you got 1, 2, 3, 4, 5, 6. How many did we want? Do anybody remember?
8.
8. Octet rule says we want 8. 1, 2, 3, 4, 5, 6. We have 7. He has a 1 to spare, so it's gonna steal it. There you go. In this case, you got a covalent bond and CH4. So you've got 1, 2, 3, 4, 5, 6, 7, 8. They're gonna share all the way around. In a metallic bond, it's basically they all just kind of stack together like this. And then you got your James Bond. All right. Other terms, bond energy in lattice energy and dipole. Bond energy is what's required to break bonds in 1 mole of a chemical. Lattice energy is associated with a crystalline lattice relative to energy of all constituent atoms, blah, blah, blah. And a dipole is a molecular part of an atom that contains positively and negatively charged regions. All right, let me have a look at our time. Let's have a look here. Covalent compounds. Maybe not. Maybe so. So here it goes. Oh, wait. All right.
Welcome to this video. I'd like to talk about writing covalent compound formulas. Covalent compounds are composed of 2 metals. You can find the nonmetals on the right side of the periodic table. Covalent compound formulas use prefixes. The prefixes go like this. Mono is 1, di is 2, tri is 2.
So we're going to try and name some in a few minutes, so pay attention.
Penta is 5. Hexa is 6. Hepta is 7. Octa is 8. Nona 9. And deca 10. It will help if you memorize these. Let's get started with a couple of formulas, and I'll go through some of the rules. Up first is COO. Rule number 1. With the first element, if it does not have more than 1, or in other words, if it's just 1, you just say the element. You don't say monocarbon. And then for the second one, you add the prefix. So this will be carbon monoxide. Up next is N2O. Now we have 2 nitrogens, so we will use a prefix of di. So it will be dinitrogen monoxide, because you only have 1 oxygen. Also notice that instead of all of oxygen for the second term, you use I-D-E-E. Next, you have N2O3. So let's put all of those together. You have dinitrogen, because you have 2 nitrogens, and then you have 3 oxygens, so it will be tri, and then you add the IDE, so it will be trioxide. Dinitrogen trioxide. Now let's work it the other way. Up first, we have SO2.
What's that going to be?
That will be sulfur, because you only have 1 of those, and it's the element
Dioxide.
name, so it'll be sulfur. Then you have 2 oxygens, it'll be dioxide. Next, you have pH 3.
What's that one going to be?
And that will be phosphorus
Phosphorus
trihydride.
Is that hydrogen?
And finally,
Yeah.
you have CH4, which is carbon tetrahydride. So there we go, naming covalent.
Now you find that there are rules, and next year we'll talk about them. But there are rules about how you end. In this case, they were all "-ide", but there are going to be all kinds of different prefixes that tell you about the structure of the molecule. So there's "ite", "ate", "ide", "aid". You'll find a lot of them. All right, so let's guess. Are we ready? What's the common name?
Hydrogen peroxide.
Yeah, that's what we call it, right? We call it hydrogen peroxide. And what's the chemical name? Hydrogen peroxide. Very good. Now, what is the formula? Hydrogen peroxide.
So it's hydrogen and then it's oxygen.
Hydrogen and oxygen. Very good.
What is per?
Dioxide.
What does per mean? Ah, that's a
Yes.
great question. All right, so
No,
let's
it's
look.
not 6, it's 4.
H2O O2. Okay. This per has to do with 4 all the way across, and this one's a little different, kind of breaks the rule we just learned, right? You would think it's just like, you would think it's dihydrogen dioxide, right? But the per means something else. And next year we'll get into that. Okay, what's this?
Because it's like two.
Yeah. Clorox. So what's our common name for this? Bleach, right? What do you think is the chemical name for bleach? Well, that's a clue. You see chlor in there, so
Chlorine.
there's probably some chlorine in it. If we look right there, it says sodium hydrochlorite and other stuff. So what might be in Clorox? Do we, whoopsie. So sodium perborate. Wait a minute, where's the chlor? There's no chlorine in Clorox. There's no chlorine in Clorox. As you can see, there's no chlor. So why would it say Clorox? What do you think? Why do you think it says that?
Maybe it's the ox at the end.
The ox,
Maybe
there's
it's
definitely some
chlor at the
oxygen in it.
Probably the or.
I think it has something to do with trying to make the product sound as if it is a good cleaning agent, and we do tend to think of chlorine being involved in cleaning agents. So there is no chlorine in Clorox. Who knew? So sodium perborate. All right. What's this one?
Borax.
Borax.
We've had that exact one.
Yep, I do too. What do you use this for?
Cleaning
Cleaning,
clothes.
stain removing,
What else do you use it for fun?
do
Do you make slime with it?
yeah.
Yes. Okay, all right. Chemical name, sodium tetraborate decahydrate. Okay,
Deca is.
Deca, 10.
deca's 10.
Touch.
So the first one, what's the first molecule gonna be?
Two.
Two.
Sodium, so Na, right? Tetraborate, not tetraboron.
NA.
8. Now we have an 8.
Tetra is 8.
And then decahydrate.
S.
What's
Deca-
hydrate?
NA. Ha
Water.
ha.
Water. How many water?
10.
10 water. Okay, we're getting somewhere. Let's see. You got the 10 water there, Darcy. Borate is a boron attached to an oxygen. So in this case, oh, hang on. Emily's running a little late, sitting in traffic. Okay. Be safe. Sorry, she's texting me. So yes, sodium tetraborate. There's your tetra right there. See the 4?
What?
Decahydrate. All right. How about this guy? Anybody know what that is?
A potato chip.
What's it called? Sponge. Not.
No,
That's
a
a-
loofah.
That's a rock. It's hard. What if I told you it's called brimstone?
Brimstone.
Where have you heard of that?
Minecraft.
Minecraft? Any of you guys heard brimstone anywhere else?
No.
Hellfire and brimstone raining down from the heavens. It's very biblical. Brimstone. Fires and
Is that
Yoink.
Is that sort of sand like a compacted?
so what if I said it smells really bad?
I believe you. It looks like it's.
Good job, Nico. It is sulfur. So if you hear brimstone, it is sulfur. It's just sulfur. So what's the chemical formula?
Oh, sulfur.
So what is it?
No.
It's just S. It's just sulfur. So that's brimstone for you.
Finally, something uncomplicated.
All right. What's that stuff?
Tartar.
Yes. What do we use this for?
Meringues.
Meringues. You do use cream of tartar
My
in
mom
meringues.
found a way to do it without cream tartar, and they're delicious.
Oh, yeah? Yeah. So cream of tartar you can use for meringues. You can use it in other things in the kitchen, but it tends to be like, it helps make your food light and fluffy, deliciousness. Anybody have it in their kitchen? I have cream of tartar in my kitchen. Yes, cream of tartar. So that's what we call it.
I have salt in my kitchen.
You want to guess okay, we're creaming something. What's tartar?
Tartar.
Tartar sauce?
Tartar
No.
sauce.
Tartar sauce. Yeah, I kind of always go there, but there's no cream of tartar in tartar sauce, so.
I think there would be oxygen in it because it makes things light and fluffy.
Okay, that's a good guess.
Water because
Okay, I like these guesses. All right, so here's its chemical name. Potassium hydrogen tartrate.
Okay, I'm done.
So potassium is gonna be what? What's potassium?
Potassium is 15.
Banana.
It's
Oh,
19.
wait, no, it's 19, my bad.
15 is phosphorus. Potassium's K. It's one of those ones, when you hear, people say vitamin K, you ever hear people say, that's
Yeah, I
potassium?
think my mom
Potassium.
says that. She takes everything.
Mhm.
Potassium.
Potassium is essential for life. You have to have potassium in your body. Potassium and sodium. You see how they must be chemically similar, right? Because they're right on top of one another. You need that for your cells to communicate. It's absolutely essential. Yep. So what, potassium, hydrogen, so we have K. What's next? Potassium, hydrogen, what's next? K?
Okay, hydrogen, so
H. K.
K, H, all right, tartrate? All right, I'll give you that one.
H4.
Tartrate is C4H4O6.
Wait, what?
Yep, that's where we get tartrate. Okay, so this just, so when you see cream of tartar, what you're talking about is the tartrate chemical that's in it. Who knew? You spend your whole life wondering what tartar is? I actually looked it up years and years ago because I was like, what is this? I use it and I don't even know what it is.
I could
Yeah.
go for a meringue.
I love a good meringue. Mhm.
Potassium reminds me of a made-up element from Phineas and Ferb called potassium infinitenite.
Oh, I love Phineas and
Let me
Ferb.
just have
No, I
something.
can't wait. Did you know they're coming back?
No, that's great news.
Yeah, Oppenheimer announced it back in last February.
I love it.
I spent my entire life wondering how did he pull his shirt on?
Over that head? That's a great question. All
What's the intro for second?
right, what's this one? What's this? What's the common name here? You boys good there? Nico, Lewis? What's this?
Epsom salt.
Epsom salts. Who uses them? Anybody use them? I use them like almost every other day.
Bathtub.
Yes,
Yeah.
I love my soaking.
Like after a
Mm.
gymnastics competition.
Yes, I do too. It's like, it's lupus relief. I slide into that bathtub and I'm very happy with sitting there. All right, so what's the chemical name?
Probably epsinidine.
Epsinidine, that's a great guess.
What a hype this really?
So it's a salt.
Sodium, there's sodium.
I'll give you a hint. It's gonna be one of these with one of these.
SR. SR was
bromine.
Yeah. It's gonna be one of those orange ones, the alkaline earth metals, and a halogen.
Bro,
Maybe
I
one,
can't see.
maybe this. 53.
Iodine? Maybe iodine?
I think it's sodium.
Calcium?
Iodine.
Calcium iodide? Calcium iodide. So let's see.
Magnesium.
Magnesium sulfate. Oh, I meant to say here, not there. Magnesium sulfate heptahydrate. Okay, I guarantee you guys can get real close to figuring out this chemical formula.
Uh-huh.
Real close. Magnesium is what?
12.
Mg, right? Sulfate. Do you remember we had an 8 a little bit ago?
Yeah.
What was in it?
Oh,
What was added to that element to give you the 8?
tetrasulfate.
We had an 8. So if it's sulfate, it's gonna be sulfur, and what do you think? Still thinking? How about heptahydrate? We know what heptahydrate is.
Water.
How many?
Hepta
10.
seven.
Hepta, 7 water. Okay, magnesium, sulfur with something else,
Sulfate.
and a heptahydrate.
You ate and left.
Your
it.
sulfate, there's your O. It's the bonding of the oxygen that makes something an 8. Okay, so you've got magnesium, sulfate, heptahydrate. So MgSO4 with 7 H2O. All right, let's see what's next. All righty, what's this one?
Freon.
Freon. It is Freon. What's Freon? What do we use
Gas.
Freon
For
for?
your,
Helium. Grill.
Not for the grill.
No, that's helium.
No. Nope.
Balloon.
Anybody like air conditioning?
Yes.
Yeah, the chemical that makes that possible.
Coolant. Air.
Freon, did you say that? Yes, and sometimes they'll say we have to charge your system. That means they're pumping Freon into your system. So there you go. Yeah, they put it in your car, like when you have air conditioning in your car. Yes, Freon. Okay, anybody want to even guess at the chemical name of Freon?
Freon.
Some kind of a coolant. Yeah, it's definitely, it says even here, it says refrigerant, automotive refrigerant. So this is Freon
Oh,
for
we-
cars.
Coolant into, one of our.
Oh, you're thinking of antifreeze in your radiator.
Yeah.
That's the this one's a refrigerant, not a coolant. Okay, so here's Freon. Oh, anybody want to try it?
Dichlorophenol.
So here's the thing. You have to know when to separate your prefixes from your chemicals. So if you look at that, you see dish, right? But what you have to know is guys, you have to know it's gonna be a dye.
Dye.
So dichloro, difluoro, methane. So I bet you can tell me what the first two parts are.
Chlorine.
Di meaning how many?
Ten.
So Cl2, then what? Cl2, here's fluorine,
F2.
F, what?
F2.
F2, methane. Oh,
Oro.
methane's a little different. So there you go. C2, actually, what's the dye? Oh, there's usually I think I'm missing a 2 here. I think I'm missing a 2 there. Yeah, no, when I found it, you didn't find it.
Give yourself a brown.
I'll double check that. So difluoro, methane. Let me double check Freon chemical formula. I think I'm missing a 2 there. Freon. No, it's not. It's either. That's right. Well, then why is it di? Difluoro. Oh, no, this says it's not di. This one says, so the resource I got it from had it listed wrong. There you go. All right, so then there it is. All right, next up, whoops, sorry. No, you saw it. What's this?
Galena.
Galena. Okay, what's galena? All right, galena is lead to sulfide. Oh, lean. You're right. Now that is the brownie point. Y'all caught that one. Lead to sulfide and PBS. What's PBS?
The TV show.
The TV channel.
PBS Kids.
Yes, it's like your PBS Kids channel. So if you looked at that, that 2 has a meaning as well. And that more, we'll do that next year because it gets a little complicated. All right, what's that?
Vodka.
But that's not vodka. That's a very specific kind of alcohol.
Tonic. No.
No.
Anybody know what that is?
Whiskey. Grain alcohol.
Grain alcohol. Okay.
It says on the bottom.
Typically made from corn
Oh.
and very, very high proof. Do you know what proof means when you're talking about alcohols?
Like very.
Proof is your percentage of alcohol. Okay.
Very
So
strong.
it's 90%
Mhm.
alcohol, 2% corn.
Right. 98. Well, actually, I think that's actually says it's 80% alcohol, but what, or 60% alcohol. But anyway, this is the kind of thing that like 120 proof. So I know it's 60%. So proof is double the percent. So 120 proof means it's 60% alcohol. So this is the kind of alcohol that like nobody should be like straight drinking. This is for mixing stuff, but you can also straight light it on fire. Woo! You could pour a light of it across the counter and it would go straight up.
Is it like one of those drinks where you light it on fire and then blow it out and then drink it?
Kind of. You can do that with most alcohol, but this stuff is highly flammable. It's highly flammable.
it's
It also evaporates very
What if you
quickly.
like to like kill someone, just like pour it on and then light a match.
Yeah, it's very, very. So there are some alcohols that are drinkable and there are some alcohols that are straight up poisonous. And some of those poisonous,
they make them?
well, some of those, no, I mean, you don't drink them, but some of them are produced like in a distillation process when you're trying to get alcohols, which is that's how you make like drinkable spirits, but it's also how you make alcohol, like for any other kind of use, rubbing alcohol, any of that, right? But you have to remove the poisonous alcohol from the non-poisonous alcohol. That's part of the process. It's part of how they, in the production. So ethanol is the name. Now, if it says
Isn't that like straight gas? Like I've seen ethanol at the pump. before.
that's alcohol. When you see ethanol at the gas station, that's
So your
alcohol.
car's gonna be all like drunk the next.
Kind of, well, think about it. What did I just say? It's very what?
It's
Or
very
what?
high percentage.
If you put a spark near it, it's gonna,
Explode.
so it's very, very flammable. So if you mix it with petroleum-based fuel that's also flammable, you just have a very flammable mixture, and you need flammable mixture for your internal combustion engine to run, right?
I know how to make a
Yeah,
bomb with Febreze.
My
Mhm.
parents' old car could run on ethanol.
Mm-hmm.
Yeah, it's an old. My friend.
Yep, you can run on
My
ethanol.
friend told me how to make a flamethrower using PVC pipe, a
Mhm.
match, and a bug spray.
Oh,
Wait,
okay. Probably because there's alcohol in the bug spray. So anyway, this is ethanol, and ethanol is the specific type of alcohol that can be consumed. It's the non-poisonous one. Obviously, too much of it is poisonous, right? People can get very,
Too
very
much of
sick.
Any alcohol is poison.
Yeah, too much of any,
You
absolutely.
get alcohol poisoning.
You can get alcohol poisoning.
That's true.
drunk as
That's the
well.
reason I'm never drinking.
I'll tell you one cautionary tale. When Jason was at Virginia Tech,
Yeah.
his first year, there was a girl there who went to a party and drank way, way, way too much. Got alcohol poisoning, and her roommates and stuff took her back to her room and put her to bed.
Did they turn her on her side?
They did, but here's the weird thing, that dorm had windows that were about this wide. Somehow, she went out the window. Like, she was so gone that she managed to fall out of that window like 4 or 5 stories and die.
Goodness.
A freshman, so at 18, not that much older than you. So that is,
Underage.
you gotta be, yeah,
Not bad.
not a great
Oh,
thing.
guess what?
Hmm.
At my friend Shannon's school, she goes to private school, my
Yeah.
There's this boy, this is like the second time he's been caught day drinking. And
Oh.
she's in 8th grade, and he was caught
Okay,
day
adults
drinking
shouldn't be
instead.
day drinking, certainly not 8th graders. All right, so the chemical formula for this is going to be C2H5OH. That tells you that the O and the H are bonded together. That's a hydroxide, but in this case, they're not. All right. So lastly, I think this is the last one or second to last one. What's this?
Pencil lead.
Yeah, what's the common name for pencil lead?
Just lead.
Is it lead?
Graphite.
Graphite. It is graphite.
Yes.
So it's not actually lead, it's graphite. What is graphite?
Graphite is.
Very light. Carbon.
Yes, it's carbon, Emma.
Wow.
Perfect. It's carbon that is just a little less compacted than other forms of carbon. What's on my left finger?
A ring.
With a
What's in the
diamond,
ring?
And the diamond is carbon.
The diamond is also carbon, carbon under extraordinary pressure.
So if you got lots of carbon and squished it together, you make a diamond.
Yeah.
Isn't that what people do with like coal and stuff?
Yes, so it starts as graphite, then it's coal, then eventually if you squash on it long enough, it can be carbon. Yep.
Then it's C.
So there's, yes, there it is. Then it's C.
For 10 years, would it turn into a very, very
Oh,
small
this one
diamond?
too. No, nowhere near enough pressure. Do you know what this is?
Well, here 8,000.
Wait,
Wait, no,
paper,
that's.
Anybody ever done construction in their ceiling or walls?
Drywall.
That's drywall. What's drywall composed of?
Drywall.
No, that's
Gypsum. Mhm. Which is calcium sulfate dihydrate, which is CaSO4. There's that sulfate again. 2H2O. One, I think this may be the last one. Did you get this morning at the dentist?
No.
What do they call this at the dentist?
Laughing gas mask.
Laughing gas,
Oh
right?
gosh, I hate
What's
that. It
laughing
hurts my
gas?
nose.
It is dinitrogen oxide.
You actually laugh when you.
Did you get a
Some people do.
And
N2O. Very good. Oh, a couple more.
Oh, pesticide.
This is actually lime that you put on your lawn. You ever
I had Lyme disease.
Back in the day, they didn't used to paint. Oh, that's different. Back in the day, they didn't used to paint the lines on fields. They would like lay them out with white powder that was lime, which is calcium oxide, which is CaO. And then lastly, this is limestone, which is calcium carbonate, which is CaCO3. There's your Lewis dot diagram. We got to roll real quick.
Lewis.
It's time. Yep. And y'all can look at that later. And let me see, is there anything else here that I need you to see? Cause it's time to move on. So, yeah, there's a little bit left to look at. Y'all can look at it, but nothing major. All right, so,
We don't need any lab.
I need to bring my bag, 'cause it's got all my stuff in it.
yep. Somebody want to tell the other crew to round up?
Come here.
Okay, we don't need to whistle for him, not too loud.